Hey guys, today we'll be learning about Unit 6.1, which is Plant Nutrition, Photosynthesis. Okay, photosynthesis, it's a process by which plants manufacture carbohydrates from raw materials using energy from light. That you have to memorize. Okay, and these are the two equations you need to know. There's the balanced equation for supplement and the word equation for core, but if you're taking a supplement you need to know both of them. Anyways, so I'll just read through everything. Chlorophyll transfers light energy into chemical energy in molecules for the synthesis of carbohydrates. Outline the subsequent use and storage of carbohydrates made in photosynthesis. Okay, I'll be doing that first. Now, photosynthesis. It's a chemical process by plants which produces glucose by raw materials using energy from light. Now, the balanced equation for it is 6 CO2 plus 6 H2O using light and chlorophyll, light energy actually, or sunlight, gives C6H12O6 plus 6O2. In other words, carbon dioxide plus water using light energy and chlorophyll gives glucose and oxygen. Now, carbon dioxide, where does it come from? Carbon dioxide, it's diffused through, it's by diffusion through stomata, through the stomata of leaves, and it's from the surrounding air. Okay, that is carbon dioxide. Now, water. Where does this come from? Water, it's absorbed or taken in. It is taken in by osmosis. By root hair cells in roots to the leaves with the help of xylem vessels. Okay. Now I'll highlight the importance of light energy in a while, but chlorophyll, make it purple. So chlorophyll, I'll talk about it over here. Now, chlorophyll is a pigment. It's a green pigment. In chloroplasts that capture sunlight and transfer light energy into chemical energy into chemical energy for photosynthesis. For photosynthesis. By the way, chloroplasts are the main site of photosynthesis. Okay. Now, chlorophyll itself contains it's a mixture of 4 things: chlorophyll A, chlorophyll B, xanthophyll, and carotene. I'll just write it properly. Carotene. Now, that is chlorophyll, and its main job is to capture sunlight and transfer light energy into chemical energy for photosynthesis. Now, the glucose. Glucose is either there are many things that can happen with glucose, so I'll highlight them over here. So there's 6 things that can happen. 1, 2, 3, 4, 5, 6. So BOCCCC. It's built up into it's built up into starch, and whenever it's starch, it's for storage. Okay, O is for oxidized, so it's oxidized for energy. C means capture and converted, not capture, converted. And all of these are converted into sucrose to be transported around the plant, like the stem to the leaves to other parts of the plant, and then converted into lipids for storage in seeds, as an energy storage in seeds. Energy storage in seeds. Sucrose, lipids, cellulose, and cellulose is for cell walls, and proteins. Proteins is for growth. So the main uses of glucose are that it is built up into starch for storage, oxidized for energy, converted into sucrose, converted into lipids, converted into cellulose, converted into proteins. And those are the reasons why. And this oxygen is either excreted by this diffusion through stomata, or it is used in respiration. It is used in respiration. If not used in respiration, it is excreted. Now that is photosynthesis, but those are the main things. Now the process of photosynthesis, this is how it occurs. So sunlight energy is obviously captured. Energy means ATP. So ATP. And plus water molecules. Now, this sunlight energy, what does it do to water molecules? It breaks it down into hydrogen and oxygen. This oxygen, it goes out of the cell either for respiration or excreted. Okay? Now this hydrogen, this part where water molecules actually are broken down and ATP is also released. This part is called the light reaction. Okay, now when hydrogen, I'll write it again here, hydrogen plus ATP, so this ATP plus carbon dioxide. So obviously in the photosynthesis equation, you get carbon dioxide, these are the two reactants, and then you get these two. So you already got this and you already used up this. So now carbon dioxide, which was given in the beginning, hydrogen, ATP, carbon dioxide, they together produce glucose. And this reaction is called the dark reaction. And a limiting factor of the light reaction is light. So you need light over here. However, for the dark reaction, temperature is the limiting factor, right? So till here it is done. Now investigate the necessity for chlorophyll, light, and carbon dioxide for photosynthesis using appropriate controls. Those are okay, yeah, so those are experiments. Necessity for chlorophyll, light, carbon dioxide for photosynthesis using appropriate controls. So first of all, one thing you need to know is how to destarch a plant. Destarching a plant means to leave it in complete darkness for about 2 to 3 days. Okay, and what it does is that if this is your plant, to test for photosynthesis, you do two things for photosynthesis. Either you photosynthesis, you either test for the production of starch or the production of oxygen. Now, if you're checking for the production of starch, you have to first destarch a plant. To destarch a plant, why? The reason is that you need to show that there is a production of starch. If you already have starch, you cannot show the production of starch if your plant is not destarched already. So you have to show the production of starch. Yeah, so you are. I don't like this card.